In this video, we're going to look at the examples in section 2.3. We're starting here with this example on page 4, which asks us to find the intersections of these sets. So starting with these first two sets, we're asked to find the intersections of the set that includes 3, 4, 5, 6, and 7, and the set that includes 4, 6, 8, and 10. So the intersection is every element that is in both sets. So we look and compare. 3 is not in the second set. 4 is in both sets. 5 is not in the second set. 6 is in both sets. 7 is not in the second set, and 8 and 10 are not in the first set. So our intersection is the set that includes 4 and 6. Next, we have the intersection of the set that includes 9, 14, 25, 30 with the set that includes 10, 17, 19, 38, and 52. Notice that none of the elements in one set are in the other. Therefore, the intersection of these sets is the empty set. Finally, we are given the intersection of the set that includes 5, 9, and 11 with the empty set. Well, there are no elements in the interset, so any intersection with the empty set is itself the empty set. Moving on. Now we're going to look at the problems on page 8. We start with this first problem about unions, and we'll just move through the next couple as we go along. One. Okay, so first we're asked to find the union of the set that includes 2, 4, and 6 with the set that includes 4, 6, 8, 10, and 12. The union of two sets includes every element in each set. So here we take the 2 from the first set, and then the 4 and 6 are in both sets, and then 8, 10, and 12 are in the second set. So our union is the set that includes 2, 4, 6, 8, 10, and 12. Next, we have the union of the set that includes A, B, D, F, G, and H with the set that includes C, F, G, H, and K. Well, then that's just every element that's in both sets. So we've got A and B from the first set, C from the second set, D from the first set, F is in both sets, G is in both sets, H is in both sets, and K is in the second set. Finally, we've got the union of the set that includes 3, 4, and 5 and the empty set. The union of any set with the empty set is the original set. So this is just the set that includes 3, 4, and 5. Next, we're going to do some more complicated stuff. We've got a universal set that includes the numbers 1, 2, 3, 4, 5, 6, and 9. Set A includes 1, 2, 3, and 4. Set B is 2, 4, and 6. And set C has 1, 3, 6, and 9. And we're asked to find the intersection of the complement of A with B. To do that, first we want to find the set that is the complement of A. Well, 1, 2, 3, and 4 are in A, so the elements that are not in A are in its complement. That's going to be 5, 6, and 9. And then we take the intersection of that with B, which is 2, 4, and 6. Well, then we just look for the elements that are in both of these sets, and that is only 6. So this is the set that includes only 6. Next, we're looking for the union of the complement of B and the complement of C. Well, the complement of B is everything that is not 2, 4, or 6. So that's 1, 3, 6, 9. And sorry, not 1369, 1359. And C is 1369. So its complement is 2, 4, 5. Then their union has all elements in both of these. 1, 2, 3, 4, 5, and 9. No 6. That's the only element that isn't in there. Now we want to take the intersection of A, 1, 2, 3, 4, with the union of B and C complement. B is 2, 4, 6. C complement is 2, 4, 5. Then that's the intersection. Make sure you guys can see this. There we go. That's better. Of 1, 2, 3, 4 with the union of these two sets, which is going to be 2, 4, 5, 6. So when we take the intersection, that's just going to be 2 and 4. Finally, we're looking for the complement of the union of B and C. So this is going to be 2, 4, 6 union 1, 3, 6, 9. And then we take the complement. Okay, well, that's going to be 1, 2, 3, 4, 6, 9. Complement, but that's every element in the universal set except for 5. So this is just the set that includes only 5. Next up, we're asked to describe in words these sets. We've got the intersection of A with the union of B and the complement of C. Which we could say is the elements that are in A and trying to think of another way to say this, B and not C. I guess that'll do. We just have to make sure that we put that together. As we say, or not C. That's a little better. Here we've got the union of A of the complements of A and C intersecting the elements, the complement of B. Okay, well, that could be the elements that aren't in A and the elements that aren't in C but also not in B. Moving on. Next, we're going to look at these set differences. I get the page ready for us. There we go. Okay, so looks like that might have nosed over a little bit. That's better. Okay, so first we want to find A minus B. Okay, well, A is 1, 2, 3, 4, 5, 6, and B is 2, 3, 6. So now we want to take everything that's in B and remove it from A to get 1, 4, 5. There's our difference. Now we've got B minus A, and that's going the other way around. 2, 3, 6 minus 1, 2, 3, 4, 5, 6. We can't pull out stuff that's not in B, so we're just looking to remove the stuff from B that is in A. Well, that's everything. 2, 3, and 6 are all in A, so this becomes the empty set. Finally, we're looking at A minus B union with the complement of C. So we've already done A minus B, that's 1, 4, 5. And then we take the complement of C. Okay, well, C is 3, 5, 7, so its complement is 1, 2, 4, 6. And then we take the union, which will be 1, 2, 4, 5, 6. Moving on. Now we've got a couple of true-false statements we want to examine. Here we're talking about ordered pairs and asking if these are equal or not equal. Well, is 3, 4 equal to 5 minus 2, 1 plus 3? 5 minus 2, 1 plus 3. 5 minus 2 is 3. 1 plus 3 is 4. So this is true. They are equal. Next, we ask if 3, 4 is not equal to 4, 3. And that's also true because ordered pairs have order. We have to maintain the order. So this is also true. Finally, we're asked if 7, 4 is equal to 4, 7, and that's false because these ordered pairs do not maintain the same order. Next up, here we're asked to find the Cartesian products of 1, 5, 9, and 6, 7. We're going to take first A cross B and then B cross A. Okay, well, A cross B just means we take the first element of A, 1, and take the first element of B, 6. And then we'll take the first element of A, 1, and the second element of B, 7. Okay, we've done first element of A, each element of B, so now we do the second element of B. We get 5, 6, and 5, 7. And then we take the last element of A, 9, 6, and 9, 7. So there we go. There are there is our first Cartesian product. For B cross A, we go the other way. We start with B, so we get 6, 1, 6, 5, 6, 9, 7, 1, 7, 5, 7, 9. Now we're talking about cardinal numbers. We want to find the cardinal numbers of A cross B and B cross A. And here's the thing. Most of the time these are equal, and certainly with these sets they are equal. To find the cardinal number, we count the number of elements in A, and we count the number of elements in B, and we multiply. The only time that it's something other than the product of the number of elements in each set is if they share an element. Okay, so there are 7 elements in A and 3 in B, so the number of elements in A cross B is equal to the number of elements in B cross A is equal to 21. Here we're given the number of elements in A and B. The number of elements in A is 24. The number of elements in B is 5. So n of A cross B equals n of B cross A equals 120. Okay, now we're asked to draw Venn diagrams similar to this figure and shade the region or regions representing each set. There's another example we'll get to when we're done with this one. So first we draw a Venn diagram. Here is A and here is B, and we'll label A, sorry, that should be U, the universal set A and B. And first we want to find the intersection of the complement of A and B. So that's everything that's not in A and is also in B, and that's going to be this region right here. Then we want to find, we're going to draw the same Venn diagram to start. I always do that. We're going to take the complement of A and the union of the complement of A with the complement of B. Well, the complement of A is everything that's not in A. So that's everything in the universal set that's not in A, plus this stuff. Well, I mean, you know, that's going to be all of this stuff. Since we're taking a union, that all has to be in there. The stuff that's not in B is that stuff outside of both, plus the stuff that's in A but not in B. So we get this set that has everything except this little place in the center. Next up, we are given 3 sets, the universal set A and B, and we're supposed to draw a Venn diagram and place the elements of the sets in their proper locations. Draw a nice big set so that we can do this properly and see what we're doing. So here's the universal set, here's A, and here's B. Okay, so we start looking at A and B and see what elements they have in common. We see that A has T and V, and B also has T and V. So T and V have to be in that intersection of the 2 sets. Now we take the stuff that's in A but not in B, R, S, and U, and that goes in A but not in B. We take the single element that's in B but not in A, X, and that goes there. Finally, we go back to the original set and look for the stuff that's not in either of them. So Q is in the universal set, but not in A or B. RST we've accounted for, UV we've accounted for, W, Y, and Z are in the universal set, but not in A or B. Coming up to the final part of this, no, I didn't. Okay, so we want to shade, I think I missed this one. Okay, we want to shade the set A intersect B A complement intersect B complement intersect C in a Venn diagram similar to the one below. So let me grab a fresh sheet of paper because I didn't set this one up. Okay, so here's A, B, C, and of course the universal set. And we want to find the stuff that is not in A and not in B and in C. The intersection of A complement and B complement is going to be everything that is not in either of them. And then the stuff that's in C and not in A or B is this stuff here. The other question we were asked on this page, suppose A and B are subsets of U. Is the statement A intersect B complement is equal to A intersect A complement union B complement true for every choice of sets A and B? So let's take a look at that one. And the way we do this is just to draw the Venn diagrams. Okay, so we're looking, we take, here's A, B, U, and we're looking for A complement B intersect, or A intersect B complement. Okay, so we're going to take the stuff that intersects and take everything outside of that. The stuff that intersects is right here, so everything outside of that is everything except that stuff right in the middle of them. And then we do this. And for this one, we're going to sketch A intersect union B intersect. Oh, sorry, A complement union B complement. Okay, well, there's A and there's B. Okay, well, the stuff that's in A complement we saw before. That's actually B complement that I'm doing right now. So we'll do B complement first. And then we also shade that because that's in A complement, and that's exactly the same sets. So the answer is yes, this is true for every choice of sets A and B. Okay, now on to the very last slide. Okay, so for these Venn diagrams, we want to write symbolic descriptions of the region in color. Well, I shaded them rather than coloring them because I only have black markers on me. So first we've got this one where we have this spot in the middle, and we can call that the intersection of A and B, not their complements, just A and B, with the intersection with C. We're just taking the intersection of all three of these. For this other one, there are a bunch of ways to do either of these, but the one I'm thinking of right now is the union of the complements of A and C with and intersected with B. That's it for this video. If you have any questions, please do get in touch.